At the very beginning of root growth, there are already three systems of primary tissues formed in the seed embryo: dermal, ground, and vascular. The system of dermal tissues, or the skin, is also called the epidermis. In young roots, all epidermal cells are approximately the same size and are tightly packed together. From the surface, the young dermal tissue is covered by a transparent film, the cuticle. The system of ground tissues forms the primary cortex. It accounts for the bulk of the root's primary tissues. Starch and other storage substances accumulate within it. The tissue of the primary cortex includes numerous intercellular spaces, air cavities necessary for supplying the root with oxygen. The protoplasts of adjacent cells are connected by plasmodesmata, cytoplasmic strands through which substances can pass from one cell to another. The primary cortex consists of two layers: the outer layer, the exodermis, and the inner layer, the endodermis. The outer layer lies adjacent to the root epidermis. In monocotyledonous plants, the walls of these cells undergo suberization during root growth and begin to perform a protective function. The inner layer of the primary cortex, the endodermis, surrounds the vascular tissues located in the center, the central cylinder. Endodermal cells are tightly packed together. Each of them has a Casparian strip on its cell walls, named after its discoverer, the German botanist Robert Caspary. The Casparian strip is a ribbon-like zone in the endodermis impregnated with a fat-like substance suberin, and sometimes lignin, a complex organic compound insoluble in water. Casparian strips protect the cell walls of the inner layer of the primary cortex, preventing the movement of substances contained in the exodermis and the central cylinder through them. Water and dissolved substances enter the central cylinder only through the plasmodesmata, while the cell walls of the endodermis pass along selectively. The endodermis also prevents solutions from leaking out of the central cylinder. Thus, all substances entering and leaving the central conducting cylinder must pass through the protoplasts of the endodermal cells via the plasmodesmata that connect the cells of the primary cortex and the central cylinder. This constitutes the physiological function of the endodermis and the Casparian strips. In monocotyledonous plants, the primary cortex is preserved throughout the life of the root, and secondary walls form in many of its cells. Over time, a suberin lamella, consisting of alternating layers of suberin and wax, followed by cellulose, is deposited along the entire inner surface of the cell walls of the primary cortex. Most dicotyledonous plants shelter the primary cortex quite quickly, and the secondary cortex forms in its place. The system of vascular tissues of the root includes xylem and phloem. In most roots, the vascular tissues form a solid cylinder, while in some, a hollow cylinder around the pith. In young roots, the central cylinder consists of vascular tissues surrounded by the pericycle. Xylem occupies the central part of the root, and phloem is located around it. Later roots are not only formed from pericycle cells. The pericycle also participates in the formation of the first layer of secondary meristematic tissue, the cork cambium or phellogen. On the outside of the cork cambium, layers of dead cork cells are deposited, and their walls impregnated with suberin, becoming impermeable to water and gases. On the other side, internal layers of dermal tissue consisting of living cells, the phelloderm, are deposited. In a young root, the pericycle consists of cells of roughly equal size with primary walls, which are replaced by secondary walls as the root grows. The primary central cylinder of the root is called a protostele. Its inner part is occupied by a solid strand of primary xylem. The outer surface of the central cylinder is ribbed, and the number of ribs varies among the different plant species. The space between the ribs is filled with primary phloem. The tips of the ribs are called protoxylem poles. All primary tissues of the central cylinder are gradually replaced by secondary tissues as the root grows and the central cylinder increases in diameter.